Where did early organic molecules originate from? Did they originate from comets, the early Tholen atmosphere, or from deep sea vents? The origin of life has been a question that has puzzled scientists, even to this day. The question is ambiguous and hard to prove. There are many explanations on the arrival of organic molecules on Earth. Some of these explanations are controversial, such as panspermia. Most of these theories disagree with the Church because the Church strictly believes God is the creator of life. All of these theories do not support the Church, but rather prove a different means of how life was created on Earth. The three major theories that will be discussed in this video are the arrival of organic molecules through comets, formation of early Tholen atmosphere, and deep sea vents. There are some scientists who believe that important organic molecules may have arrived on Earth through comets and meteorites. According to Wysong,
life on Earth depends critically on a handful of biogenic elements such as carbon, hydrogen, nitrogen, oxygen, phosphorus, sulfur, and others. These elements are abundant in the outer solar system, but comparatively rare in the region of terrestrial planets.
Due to the fact that there are not too many chemical sources that we know about on Earth, it is all the more reason that scientists believe that organic chemical had to come from somewhere outside of Earth's atmosphere. Therefore, scientists believe comets had to bring organic molecules to Earth. The organic molecules formed on dust grains and in the dark molecular cloud. The reasoning behind this is that water and organic chemicals were formed in the molecular cloud. As it is seen in this picture, the solar system has prebiotic molecules, and thus prebiotic molecules are on the comet. The formation of organic material on comets is due to the chemical reaction of the atmosphere, dust, and water. Organic molecules develop on dust grains in the collapse phase as the pressure within the cloud increases. When the protostar evaporates, ice off the dust grains, the gas phase causes organics to form.
Nucleic acid bases, purines, and pyrimidines have been found in the Murchison meteorite.
The Murchison meteorite has all the necessary organic molecules for life, except ribose, which are building blocks of RNA. When explaining organic formation, it is suggested that it must come from another source, other than the surface of the planets. It must come from the solar system through another means such as comets. Many scientists agree that
Tholins are very large, complex organic molecules, thought to include chemical precursors to life. Understanding how they form could provide valuable insight into the origin of life in the solar system.
This haze may have covered Earth's atmosphere approximately 2 billion years. The organic haze was thick, and it was likely that the sun could not penetrate the haze. Although the sunlight could not penetrate, it did cause a chemical reaction between methane and carbon dioxide, resulting in the haze. Of course, the Tholen haze does have merit because of the organic chain of molecules found in Titan's atmosphere. The early Earth's atmosphere was recreated by Miller and Urey. The Miller-Urey experiment was an attempt to reform all the necessary organic molecules to recreate life in order to prove this was the origin of organic molecules. Miller and Urey filled laboratory flasks with water and put a gaseous mixture of water vapor, hydrogen, ammonia, and methane. They heated the flask, which vaporized some of the contents, into another flask connected by a glass tube. Electrical discharge was to simulate the effect of lightning. It would return to the original flask, creating a cycle that continued over and over again.
After this entirely modest time interval, Miller and Urey found the water in the lower flask to be rich in organic gunk. a compound of numerous complex molecules, including different types of sugars, as well as two of the simplest amino acids, adenine and guanine.
This can be seen in the following image. The origin of life has also been traced to the deep sea hydrothermal systems.
Impact theories led to the intriguing concept that the origin of life may have been repeatedly whipped out or impact frustrated, and that deep ocean and deep subsurface environments might have served as refuges for early life.
As stated before,
the deep sea hydrothermal system may represent suitable reducing environments for the synthesis of prebiotic organic molecules. The ejected gases contain carbon dioxide, carbon monoxide, sulfur dioxide, nitrogen, and hydrogen sulfide.
This again shows that there is a strong case that life might have originated from these deep ocean vents. Wasserschauer proposed the iron-sulfur worlds theory, suggesting that hydrothermal vents might have caused the creation of life. It may have been possible that a form of metabolism created a cycle of chemical actions to produce energy. Amino acid synthesis could have come from deep in the Earth's crust and came out with hydrothermal fluids into cool temperature water. This would have caused the formation of peptides and protocells. It is possible that there is a lack of organic molecules at hotter temperatures. The formation of organic molecules is still an ambiguous topic. Scientists still are unable to prove how exactly organic molecules came to Earth. There are many plausible theories, such as by comet, the orange Tholen haze, and the deep sea vents. All these theories could be accepted, but there is still more evidence needed in order to explain early life on Earth.